be the second time we're having revision on this course. For those of you that will be having an exam on Monday, Tuesday, being tomorrow and next month. So today we are still going to revolve around some basic things that you need to know before entering exam hall. Just like yesterday, when we talk about the introductory aspects, today I want to just give you some basic hints on arcane. Yeah, basic things that we need to know about arcane. Number one, it is a saturated hydrocarbon. Shouldn't forget that. Arcane is a saturated hydrocarbon. It's a saturated hydrocarbon. Let me use CX, C subscript S, H subscript Y to represent the hydrophotally hybridized. I think yesterday I explained the concept of hybridization, which is just no other thing than the blending, the reshuffling, the mixing together of orbitals of same energy. Sorry. Okay. So the mixing together of orbital. Please just a minute. Let me share this with my moving. Yes. Sorry, let me just share this thing immediately. Yeah, Patrick, you're welcome. I'm coming. Let me just send to my people. All right, so I think I've done that. I said when we talk about arcane, we know it as saturated hydrocarbon. And it have the general molecular formula of CnH2n plus 2. Not just that, there's something to take note of take note of here. I mentioned molecular formula. I'm going to tell you what it's all about. Then, in relation to what we call the empirical formula, it's just a revision class. And I say it is sp3 hybridized. That is arcane. And it have the bond angle, arcane have the bond angle of 109 degree 28 minutes. Or you convert it to become 109.5 degree. That is the bond angle of an arcane. It never changes. All these are the basic information you should have at your fingers tip. Now, owing to this bond angle, all arcane is tetrahedral in shape. Tetrahedral in shape. That is the shape of an arcane, tetrahedral in shape. Don't forget, we are just listing the basic thing that you need to know about arcane. I've given you the general molecular formula. The first member of an arcane being methane, conform to this formula. Second member being ethane, conform to this formula. Third member is propane. Fourth, butane, pentane. In that order, hexane, heptane, octane, nonane, and decane being number 10. Why number 11 is called undecane. They all conform to this formula. Here N here stand for the number of what? Carbon atom. Because it is the number of carbon atom that tells you how many hydrogen that need to revolve around it. So 11 is undecane. Arcane with 11, C11, sorry, is called undecane. That is arcane. So owing to this formula, it becomes C11, H, remember is 2n, meaning our n here is equal to 11. It becomes 2 times 11 is 22. 22 plus 2 will give you 24. That becomes the formula for what? Undecane. That becomes the formula for undecane. Are you seeing it now? That becomes the formula. That becomes the formula for undecane. Sorry, I'm trying to confirm. All right. Okay, I think they have gotten this thing already. So now that becomes the formula for undecane. H24. I'm still coming. Please just pay attention. I've listed basic things. Alkane is saturated. It's a saturated hydrocarbon. We have this as its general molecular formula. Of course, when we talk about molecular formula, it is the formula that shows the actual number of participating atom in a given compound. Yeah, that is what we call molecular formula. Not just that. For molecular formula, we have another formula called empirical. Empirical. Okay. So before this, we have another formula called empirical formula. Empirical formula is the simplest formula that shows the relative number of participating atom in a given compound. So I'm going to show you their relativity even as we proceed. So just like I said, I mentioned that alkane is also tetrahedral in shape. That is the shape of all alkane. In fact, what defines something as an alkane is usually your carbon-carbon single bond. And anytime that you see carbon-carbon single bond, this type of the type of hybridization that revolve around this is said to be what? sp3, which is being conformed with this particular what? Bond angle. And that bond angle is what make it to be what? A tetrahedron, which is their what? Geometric shape. I'm still coming. Please just pay attention. And don't forget that the most peculiar reaction that alkane undergo is what? Substitutional reaction. Yeah, substitution, or you call it substitutional reaction. That is one of these are the basic things to know about. Don't don't mistaking this to maybe probably combustion reaction rather. Combustion reaction, all hydrocarbon undergoes it. So I'm still coming to that. Now, alkane, the first member I have listed, at least now know from number one down to even number 100. Yes, it's possible. The first one, number one, is called methane, which is CH4. Number 100 is called heptane. That is alkane. First member of an alkane is methane. Second member is ethane. All of them end with ANE. That is the family name of alkane. ANE. So first member met. Second eth. Third prop. So you add all this ANE. Methane, ethane, propane, butane, pentane, no pentane, being number 5, hexane number 6, heptane number 7, octane number 8, nonane number 9, decane number 10, undecane, you know this one, on from French, yeah, undecane number 11, that is number 11, alkane with 11 carbon atom. Dodecane should be number 12. Dodecane should be number 12. Tridecane number 13. Tridecane, of course, tetradecane is number 14. Pentadecane is number 15. Hexadecane, heptadecane, octadecane, nonadecane, nona is number 19. And ecosane is number 20. Look at this, ecosane. Ecosane. That is alkane with 20 carbon atom. Ecosane. 21 hen ecosane, docosane 22, tricosane 23, tetracosane 24. In that order, reaching 29 is what? Monacosane. Why 30 is what? Triacantane. It's very easy. It's very easy to go, to peruse through all this. So all I'm saying, I want to just list basic things. Mention substitutional reaction. Let's watch out what we can get from that. Yeah. maybe I will still drop the nomenclature of what? Aliphatic alkanes. Aliphatic in the sense that on branch. Because when we talk about aliphatic hydrocarbon, there are those hydrocarbon whereby their carbon chain is either in form of straight chain or branch chain. Branch in a way, I will demonstrate that when we go into detail. So substitutional reaction is the most peculiar reaction that alkane undergo. Example, CH4 reacting with chlorine. And don't forget, just like when they say you are photogenic, it means you are not fine until they shine light on you. Are you seeing me? That is what it means. I'm sorry, I'm just joking. Now, this reaction is actually a photo-dependent reaction. Without light or UV being present, the reaction cannot take place. And when the reaction, of course, the reaction involves 3 different stages. One is what we call chain initiation, then we have chain propagation, and lastly chain termination. Let's just go straight to the point. What we form is one hydrogen will be replaced by one chlorine, and you now have CH, is the product CH3, and one of the hydrogen substituted by chlorine. Then the other chlorine, the hydrogen that move up will react with the remaining chlorine to give you HCl. And this product is called, how many chlorine? One. We call it mono. We call monochloromethane. Monochloromethane. Are you seeing it? That is substitutional reaction. Okay. Okay. Sorry, making it. Can you hear me now? Sorry about that. Can you hear me? All right. Let's check it. Sorry about that. So, just like I said, this monochloromethane are the first product obtained by the substitution reaction of methane with chlorine. Now this will still go into reaction again. CH3Cl. We still react with chlorine gas in the presence of UV. And that reaction, one hydrogen will move up again, it becomes CH2. One chlorine will join this to become Cl2. Then plus what? HCl. This is the second product. And here there are two chlorine. We call it dichloromethane. That becomes dichloromethane. Sorry, my mic is off. Sorry. Oh, God. Sorry, let me solve the issue once and for all. I just discovered. Yes, I think all right, so I can check it up now. I've solved the issue of the mic. Okay, so now let's go again. I said the second product form is going to be what? Dichloromethane. Don't forget, this is just like a chain reaction. It keep taking place. That is why there are 3 stages: chain initiation, chain propagation, and chain termination. So with this, you see, the next one is that this dichloro will still go into reaction. This is it, CH2Cl2. We still react with chlorine in the presence of UV. What will be formed? One hydrogen will move off. It becomes CHCl3 plus what? HCl. Now this product from here is what we call trichloromethane. Trichloromethane. And that is, in other words, we can also call it trivially, you call it chloroform. Chloroform. Don't forget, this is the substituted product of methane that has a medical use. It is used medically. I want you to understand that CHCl3 is used medically as an anesthetic substance. Anesthetic substance or sedative substance. Yeah, they have a medical application. Now, when CHCl3 still react with chlorine gas in the presence of UV, that will now give you the last product, which is going to be CCl4 plus HCl. Now, this is what we call tetrachloromethane. Yeah, this is tetrachloromethane. Are you seeing it? Tetrachloromethane. This one has an industrial application. It has an industrial application. In the industry, we use it as a solvent to remove grease. It is an industrial solvent for removing grease. It's an industrial solvent for removing what? Grease. We use it in the industry to remove grease. Like grease stains. Are you seeing it? In the industry, to remove grease stain. We use it in the industry to remove grease stains. Yes. And I want you to understand that combination of this trichloromethane, this is CHCl3 plus CCl4, give you another product which we call dry cleaning agent. Or sorry, dry cleaning solvent. Yes, or dry cleaning agent. Dry cleaning solvent. Please do well, even as you have joined us here, do well to invite others. You can share to them so that they will know we are here or we're having a session here. Do well to share to them. Share. Let them come up. Yeah, Achibon, how are you doing? Okay, please do well to share to them. All right. Bring them up. So that is all. That is just the basic this thing about arcane. Then another thing I want to tell you before I go to other hydrocarbon, please look at this. I want you to just know this. Know CXHY plus what? Bracket X plus what? Y all over 4 of oxygen, which give you XCO2 plus Y all over 2 H2O. Note this, that is the general formula for combustion of all hydrocarbon, be it alkane, alkyl, alkynyl, alkynyl, or even your aromatic hydrocarbon, which is the benzene and the benzene-like substances. So far as you are a hydrocarbon, this is the general formula for combustion of all hydrocarbon. I have a formula for alkane alone. I have for alkene, I have for alkyne. But imagine you battering to know the one of alkane differently, the one of alkyne and all that. It's a whole lot. This formula can help you to achieve all the purpose. And what do you need to understand about this? What do you need to know about this? Sorry, I told you this is just a revision class. Which after this, those of you that is sitting for 2027 JAM, WAEC, NECO, JUPEB, IJMB, pre-degree, and other examination type, do well to always check up on this channel, because we'll be giving you shortcuts, not just shortcuts. We'll be giving you access to knowledge on what you're supposed to know, so that you can approach your exam hall with confidence. Yes. And don't forget to always refer others that are struggling with physics, struggling with chemistry, struggling with mathematics, biology. All these things are something that we need to give you a hack, a secret code to understanding them. So do well to keep following through, yeah, as we expose you to the hidden secrets. Now look at this. The X here stand for number of moles of carbon. Let me put it that way. And Y equal to number of moles, or moles of what? Hydrogen. Yes, that is what they stand for. I see it. For instance, we are going to burn different hydrocarbons. Let's just burn. First one is, the first member of an alkane is CH4, which we call methane. In the exam, if they ask you, why is methane called marsh gas? I hope you have something to tell them. Because it is always gotten from what? A marshy area through the bacterial decomposition of what? Vegetable matter. We call it marsh gas because it's gotten from marshy or swampy area, through the bacterial decomposition of vegetable matter. And that bacteria is known as methanogen, just from methane, methanogen. Are you seeing it now? I said there is a whole lot to learn, just for you to keep paying attention. And don't forget to drop your question where necessary. Yeah, don't forget to drop your question. Don't forget to, in case if you have a question, if you have any question, that is why once I have to turn back to check if we are still together or we have left some people behind. So feel free. John Patrick, are you still here? Patrick. And I do it to keep flowing through, because you need this. Okay. Now, another thing you need to know here is that there is also another name for methane. It can also be called fire damp. Reason being that it is gotten from a poorly ventilated coal mine. That is why we call methane fire damp. DAMP, damp. All right, let's go back to business. Here we have CH4. And what is it trying to tell you? It shows that our X is equal to 1 and our Y is equal to what? 4. Now, if you want to, using the formula, it becomes, without wasting time, it becomes CH4. Even if you do C1H4, then plus, it becomes 1 plus 4 all over 4 of oxygen, which gives us, what is our X? 1 CO2 plus 4 all over 2 H2O. That is how to balance. This is the best way to balance hydrocarbon equation. I beg you in the name of God, if you are going to be sitting for BE JAM, aside my student that is having the exam tomorrow and next tomorrow, that is Unica Year 1 student, any other exam that you are revolving around this course, know this formula. It will save you a whole lot of what? Trauma. Yeah, know this formula. This is the best way to balance hydrocarbon equation. For JUPEB exam, it comes as a theory. Usually occur as a theory question. They have asked, write a balance equation for combustion of what? Propane. And that is just it. Okay, now here, this implies that you are going to have CH4 plus 4 divided by 4 is 1. 1 plus 1, 2O2, which will give you CO2 plus 2H2O. You look at it, how many carbon are here? 1. How many are here? 1. How many oxygen are here? 4, because 2 times 2 is 4. How many are here? 2 plus this 2, that is 4. How many hydrogen are here? 4. 2 times 2, 4. So that is why I say this is the best way to balance hydrocarbon equation. That is the best way to balance hydrocarbon equation. Yeah, that is the best way. Please do well to invite others, and don't forget to keep sending likes to this so that the video can be recognized by many that need to know about this. So that is all about for methane. Well, just imagine for alkene, the first member is C2H4. The same thing, you already know, this is going to be C2H4. Our x here should be 2. It become plus 2 plus 4 over 4 of oxygen, giving you 2CO2 plus 4 all over 2 H2O. At the end, that will give you C2H4 plus 4 over 4, 1 plus 2, 3O2, giving you 2CO2 plus 2H2O. Are you seeing it now? Here, how many carbon is how many? 2. 2 times this 2. What again? Hydrogen is 4. 2 times 2, 4. Oxygen is 6. 3 times, that is 6 here. 3 times 2, that is 6. 2 times 2, 4 plus 2 here, 6. Like I said, that is the best way to balance hydrocarbon equation. The best way to balance hydrocarbon equation. Even if you want us to go to C2H2, as you can see in alkyne, in alkene and alkyne, the first member, the met does not exist. The first member started from number carbon atom 2, like carbon from 2 carbon. So the first carbon, how would I put it for you to understand? In alkane, first member started from met. All these met et prop boots come from their Latin origin. Are you seeing it now? They are Latin origin. Why paint? From paint come from what? The shape of the how would I put it? Polygonal shape that corresponds polygon, shape of polygon. As you can see, pentagon from pentane, hexagon from heptane from hexagon, hexane from hexagon, heptane from heptagon, octane from octagon, nonane from nonagon, in that order, decane from decagon, undecane from undecagon, dodecane from dodecagon, in that order. That is just what I'm trying to say. So the first member started from carbon atom 2. The same thing is applicable to this. We call this ethene. This is methane. This is methane. And the second member for this should be C2H6, which we call ethane. Now here we call this ethene. That is the first member of an alkene. Here, meaning the methane does not. We call the methane wood spirit. Don't forget homologous series. I'm still going to say one or two things about it. Now, this is called ethane. Are you seeing it now? Now, how do we balance this? This is going to be C2H2. This is how to balance. It becomes plus, bracket, our x is going to be 2 plus, remember it's 2 over 4, put it 2 over 4, no fear. 2 over 4, then what do we have again? We have 2CO2 plus 2 all over 2H, yes, 2 all over 2H2O. Are you seeing it now? Everything here will give you C2H2 plus 4 times, find the LCM, 4 times 2 plus 2. 4 times 2 is what? 8. We have 8 all over 4 of, sorry. 4 times 2, 8. 8 plus 2 is what? 10 over 4 of oxygen, giving you 2CO2 plus H2O. because when 2 divided by 2, that will be eliminated. Permit me, let me use the upper part to complete it so that you see it clearly. Now, what is the next line of action? We now have C2H2 now plus, of course, 10 divided by 4 will give you 5 over 2O2, giving you 2CO2 plus H2O. This is a balanced equation. Now, I want you to understand this is taking, how many oxygen are here? 5. These 2 that you are seeing all over, this shows that is what is taking care of this other 2. You can look at this to show you that a 5 oxygen, 2 times 2, 4, plus this 5. So let me still put it back because oxygen cannot exist this way. Oxygen cannot exist normally. If oxygen occurs, to occur this way, it will be under condition, like nascent oxygen, which is showing the work of oxidation or symbol for representing oxidation. So let's put it back. Let me tell you what to do. This is over 2. Now multiply through by half. If you multiply through by 2 in order to eliminate the half, that is going to be 2C. This implies 2C2, let me say here, times 2. Now 2C2H2 plus 5O2, giving you 4CO2 plus 2H2O. These two equations are still the same. If you are solving any stoichiometric equation, using this first one, using this or this, you can still get the same answer. That is the truth about it. They are same. These two, they are same. Take note of that. So this becomes the balance equation. Either this or this can be considered as a balance equation for combustion of what? Ethane. I'm saying this to say that know this formula. The moment you capture this formula, the better, because it will help you to, okay, let's try something. Benzene. I don't know. Let me give you just a space of 30 seconds to. Okay, so sorry. I think we are good to go. Let's try for another this thing. At least you have seen it. Let's check if we can balance benzene. I told you everything can be balanced. So C6H6 plus, definitely because 6 plus 6 over 4 of oxygen, giving you 6CO2 plus 6 over 2 H2O. And everything here will give you C6H6 plus 4 times 6, 24. 4 times 6, 24. 24 plus 6 should be 30 over 4 of oxygen, giving you 6 CO2 plus 3H2O. 30 divided by 4 should be 15 over this. Let's have this as 2 and here 15. So 15 over 2. Multiply through by 2. Everything will be 2C6H6 plus 15O2, giving you 2 times this will be 12CO2 plus 6H2O. Now let's check if it is balanced. How many carbon are here? 12 carbon. Normally 12 carbon is in a balanced equation. Balance. It's either we use this or I can still leave it at that C6H6 plus 15 over 2O2, giving us what can we call this? Normally I'm supposed to reduce this. So giving us what? 6CO2 plus 3H2O. So I can still leave it at this. It's also a balanced equation, but I decided to convert it to this one from here. So you see 12 carbon is also 12 carbon here. 12 hydrogen, 6 times 2, 12 hydrogen. 30 oxygen, 15 times 2 is 30. Now 12 times 2, 24, plus 6, 30. As easy as ABCD. This thing are just something that I want you, while flowing through, pay attention, drop your question. As I once I have to turn back in case anybody drop any question, maybe what you not perfectly understood why the class is going on. So please do well. Uh, don't feel shy. Drop your question. I'm ever ready to attempt to it. Yes, ever ready to attempt to it because okay, well, no question. I presume people should keep sending likes to the video. Keep sending likes, share to others so that they can easily just keep sending likes to the video. Drop more likes if you are here with us, please. Drop more likes. Yes. Keep sending likes to the video. Or good luck, are you still here? And for those of you that are just joining us, if you have not yet subscribed to my channel, please just click that plus sign button so that you can easily be notified whenever we're in this media space. Yeah, so just that we have to go this way. All right, that is all about it. Let's go to another distance. We have talked about arcane and we have exemplified some basic things that you need to know about arcane. That arcane is sp3 hybridized. You have the bond angle of 109.5 degree or 109 degree 28 minutes. Not just that, it is tetrahedral in shape. And what again do we need to know about arcane? We also mention the most peculiar reaction arcane undergo is what? Substitutional reaction. No, substitutional reaction. We say it is a saturated hydrocarbon. So if I ask you to give me one or two things about this nigger, don't forget an alkane that lost one hydrogen atom is called, oh, it says C6H12O6. Yeah, pavin, that is glucose. Though it can also be for fructose, it can be for even garatos. It's until we arrange it. So do you have any question attached to that? Is there anything that, okay, say, priest, did you say Chinda Marvel? Priest, what did you say about oxygen in the reaction? Oh, Chinda, and I just wipe. Is it which of the oxygen? Okay. Please, I will still turn back to this question so that let me just drop basic this thing for what do we call it for Akin. Number one thing you need to know about this guy. Don't forget, I say something about Akin. I say Akin that lost one hydrogen atom is called alkyl, and the formula is CnH2n plus 1. CnH2n plus 1. So the question can come as compared to its parent hydrocarbon. Alkyl radical is a radical because it cannot stand on its own. No, radical group of atoms that constitute a unit. Now, alkyl radical, that is as you are comparing alkyl to alkane, is dash. As compared to its parent hydrocarbon, alkyl radical is dash. They will say one less hydrogen, one less, meaning you are less than alkane by one hydrogen. We are going to that. One less carbon, one more hydrogen, one more carbon. Now, if you look at this, if this is CH4, that is methane, and you also have CH3, that is methyl. This is alkane, this is alkyl. So you see the difference between alkane and alkyl is this is alkane. Let me put it down, and this is alkyl. Because this group is gotten from this, you are gotten from alkane by removal of one hydrogen atom. That is what I'm trying to say. The alkyl is gotten from alkane by the loss of one hydrogen atom. Take note of that. Please don't forget that too. Don't forget that. Now, here, you are part of the word unsaturated. You are an unsaturated hydrocarbon. Unsaturated. Eh? You are unsaturated hydrocarbon with with carbon carbon double bond as its functional group. Hmm? Yeah, that is it. It is an unsaturated hydrocarbon with carbon carbon double bond as its functional group. That is the first thing that you need to take note about this. You have the general molecular formula of CnH2n. That is the general molecular formula of alkene. Hmm? You have the general molecular formula. This one undergo addition reaction. Addition. Why do you undergo addition? Because you are not saturated. You need something that will come into you to make you reach the saturation point. So that is it. You undergo addition reaction. Are you seeing it? So not just that, we can also talk about this, that it is sp2 hybridized. sp2 hybridized. Anytime you see carbon carbon double bond, it is sp2 hybridized. Anytime you see carbon carbon single bond, it is sp3 hybridized. Take note of this. I said this before. Why in alkane? Now, because of this, you have the bond angle of 120 degree, and owing to this bond angle, it is trigonal in shape. Trigonal, at times I tell you trigonal planar. It is trigonal in shape. Let me just keep it at that. It is trigonal in shape. All right. So, surprise, isocoric. Ah, Shamapavin. When we say isocoric process, it's a process occurring at constant volume. Are you with me? And that is not revolving anywhere revolving around this. But if what you have in mind with respect to the compound or the structure that you provided earlier on is isomers, then I will tell you one or two things about that. What you give me is C6H12O6. Eh? And yeah, it's a stereoisomer, that is glucose. It undergoes stereoisomer, which conform to the formula of 2 raised to power n, where n is the number of stereogenic center. So in glucose, I'm doing this because it's actually a question. Look at this. 3, 4, 5, 6, 7. Let me just put this as CH2OH. Now, now OH, OH, hydrogen, hydrogen, OH, hydrogen, OH, hydrogen, OH, hydrogen. I think this corresponds to the compound that you gave me. So that I just want to answer your question. If actually you are talking about, because when you mention isocoric process is a process occurring at constant volume. We call it isocoric or isometric. Then why when we say adiabatic, it's a process occurring at constant heat. When we say isothermal, it's a process occurring at constant temperature. When we say isobaric, it's a process occurring at constant pressure. So let's come back to this. Let me just assume that you are talking about isomer. Now, of course, it's going to be stereoisomer, which this is the formula, where n is the number of stereogenic centers. Now, look at what happened here. Now, first of all, I supposed to even be talking about stereogenic center or chiral centers. Now look at this. Chiral center, a chiral carbon is a carbon that have 4 different attachments, A, B, C, D. None of the attachments are the same. If you look at this, I supposed to, please, pardon me, let me put it this way. See, this is hydrogen and here is OH. and here is hydrogen. Now, this cannot be a chiral center because hydrogen are the same. The only thing that differ is OH and the whole of this compound. Now, but look at this now. This is one of the chiral center. We put an asterisk, count it number 1. Why are you a chiral center? Because what is connected here, look at what is connected. What is connected downward is the whole of this. You call it a unit. The whole of this is like CH2OH, and here hydrogen, here OH, and the whole of this up should be considered as a whole. So you are a chiral center. The same thing is applicable. You are also a chiral center. That make it 2 chiral center altogether. Because hydrogen here, OH here, the whole of this downward, and the whole of this upward. Now, you are also a chiral center. Hydrogen, OH, the whole of this, look at the 1, 2, 3, and 1, 2, 3, they are not the same because here we have a carbonyl carbon. As you can see, here we have hydroxyl. So you are a chiral. The same thing is applicable to this, a chiral center. Check it. This. Are you seeing it? Yeah. So that is it. 1, 2, 3, 4, 5, 6. Yes. Sorry. I make it up to 7, and you guys do not even tell me anything about this. This is it. It's not possible to 1, 2, 3, 4, 5, 6. Exactly. 1, 2, 3, 4. That means here glucose have 4 chiral centers. So our N is equal to 4. With that, you do 2 raised to power 4. That will give you 16 stereoisomer. If you go to the exam tomorrow and they ask you how many stereoisomer does glucose have, now 16. 16 is the answer, and I've been able to show you how it come about. N stand for the number of stereogenic centers. Yes. Oh, say SWAT down there. Say, sir, what grade of chemistry is this? Well, this can be applied to. This is basically for my student that is having they have an exam tomorrow and next tomorrow, which is year 1. Their final semester as a year 1 student. I'm just doing this to add up to what we have taught them so far. Not just that, this can also be applicable to JAM, applicable to WAEC, applicable to JUPEP, applicable to IJMB, applicable to basic undergraduate level knowledge of chemistry down to your O level. So you are safe, but maybe even in a higher learning, these are what constitutes what you are still studying over there. So please, except maybe if there's this thing, but we can talk about it later. Shama Pavin, I don't know whether I've answered your questions. Okay. All right. So just do well to drop a thumb up to confirm that. As you can see, these are just the basic this thing that you need to know about Akin. Sorry, my next live session will be on TikTok so that I can sit down and expose you to so many question papers. In fact, I think let me just drop 1 or 2. Don't forget, another name for arcane is paraffin. Why do we call arcane paraffin? Because it shows little or no reaction to organic reagents. So that is it. It shows little or no reaction to organic reagents. That is why we call it paraffin. Paraffin. Please take note of that. Arcane is called paraffin because it shows little or no reaction to organic reagents. So you should take note of that. Take note of that. Sorry, just soonest I'll be done with this session. So another name for arcane is paraffin. Another name for arcane is olefin. Olefin, that is what at times you call double bond olefinic bond. Another name for alkyne now. Alkyne will be what? Acetylene. acetylene. Olefin is talking about. Is it oil or what? Okay. For alkyne, of course, you have the general formula of CnH2n minus 2. Don't forget, alkene that lost one hydrogen atom is called alkenyl, with the formula of CnH2n minus 1. Alkenyl is an alkene. It's an alkene that lost one hydrogen atom. So this one is unsaturated hydrocarbon with carbon-carbon triple bond as its functional group. Not just that, you can also say that this guy is sp hybridized. Yeah, it is what? Linear in shape. Linear in shape. Of course, you know, angle on a straight line with the bond angle of what? 180 degree. It also undergo addition reaction. Eh? All the unsaturated hydrocarbon choose to undergo addition reaction. In case you go to the exam, benzene mostly undergoes substitutional reaction in place of addition, because benzene prefer the reaction that will reserve its structure, not the one that will convert it from aromatic to something else. So, and it is substitution reaction that can easily help benzene to be benzene and not converting. Because if you go back, not that it doesn't undergo addition reaction, it can undergo hydrogenation to turn from benzene to cyclohexane. So that is it. So, but I prefer reaction that will help to reserve its structure, its nature, and all that. So take note of this. Let's take note of that so that as we proceed, we will sure get better and all that. Okay. So that is all about this. I'm going to be dishing out some basic questions that we need to just as our now let's just go through questions questions and questions again. Yeah, let's just go through question. And I will start with this particular nomenclature that they gave this year. Look at what they asked to name. They said the IU-PAC name of they said the IU-PAC name of CH3, CH, bracket open, CH3, close the bracket, CH, then double bonding CH again, then CH2, then CH of OH, and O, CH2, then CO, and CH3. What a compound. We're asked to name this. Let me just read out the, if I can read out the options so that you see. We're asked to name this. And if you can see the, let me see if I can. Sorry, can see the compound. There you pack name for. So please, let's just, does it look like something that you can name? Option A say 4-hydroxy 8-methyl non-6N2-on. B say 2-methyl 6-hydroxy non-5N2-on. C say 2-methyl 8-ozo non-4-in 6-no. And D say 4-hydroxy 2-ozo 2-methyl non-4-in. So all these are the possible options that they gave. And I think we are going to name this together. So I want you to keep paying Rapt attention. We are going to name it together. Noun. We are going to name it. Please, if this is your first time of getting across my content, do well to click the plus sign button and subscribe. This is going to be maybe on a daily basis. Yes, on a daily basis. And you can as well drop your this thing for those of you that want to keep taking part of this exercise. Yeah, we'll have a platform that you can easily be part of so that you'll be easily notified. Yes. So do well to subscribe to the channel and refer others that is struggling with these subjects so that they will get better. Now look at this. I can't just so okay, I can still operate this way, but I want us to let's put it in a bigger picture that will make naming the hungry you. Now look at this. I'm going to have this, I'm going to transform this to CH3, then to C. Let me put hydrogen here because it simply show this carbon supposed to have every terminal carbon have three attachment, that is three hydrogen attachment. Every intermediate carbon have two hydrogen attachment. I hope you are taking note of this. Every intermediate have two hydrogen attachment. So this is just one of the hydrogen. Why the second hydrogen have been replaced by a methyl group? So I will put CH3 here. Take note. Then bonding to this. Do you see how I dissolve this now? Bonding to C. I can put maybe here that hydrogen. Then double bonding another C with hydrogen. Since because of the double bond, it's still complete. Every carbon must have 4 bonds pointing to it. Count. Even though I not draw out represent this, let's use even here. We can 1, 2, 3, 4, because these three hydrogen, one will be here, one will be here, one will be here, and this 4 pointing to this. 1, 2, 3, 4 in that order. Now here 1, 2, 3, 4 because there is a shared double bond. Okay, let's keep moving here, and you are bonding to C and hydrogen. Are you seeing it? Then which is bonding to, I would have just put CH2, but I want you to understand this. Bonding to another C with hydrogen here and OH. It shows that this OH, look at it, this OH is to this carbon. That is just it. Just like this, you are to this carbon. And then OH is to this carbon. That is attachment of the carbon. Then this connecting to another C with hydrogen, which we now have. What happened here? This is a carbonyl compound, double bond oxygen. Then C, let me still put it just as CH3. Well done. Are you seeing that transformation that we do now will help you? Naming this will become easy. Just pay attention. Naming this will become easy. Yes. Is the best thing that you have to do. Then after we have a functional group, we have OH, we have carbonyl. That is ozone. Now I want you to understand something. There is what we call functional group priority. In the absence of this guy now, I will be giving preference to OH, the hydroxyl functional group. But because you are here, I will give you preference instead of this. And that will make me to do my numbering in such a way that that functional group that have determined that determine the orderliness of this compound will be favored. We number in such a way that the functional group in this given compound will have lower number of carbon atoms. So there's nothing that will make me to start numbering from here. I will number from here in order to favor this functional group. And with that, that will be what? 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 carbon atom if it is alkane, nonane. Nonane if it is alkane, nonine if it is alkyne, in that order. But now, we just know that 9 carbon is non, N-O-N, non. Let's use that acronym or that we call that preface. Yes, that preface, non. I will not complete it. Now look at how it's going to be. We are going to take notes. There's no need to say name this, do this. We are going to name every other attachment like this. Look at this. Alphabetically. With that, we have hydroxyl, we have methyl. Which one come first? Hydroxyl and methyl. Which one come first? Which one do we name first? Alphabetically. Someone should say something. Hydroxyl and methyl. Which one do we name first? Oh, okay. Mhm. All right, so we're going to name it as 4 hydroxy. 4 hydroxy, 8 methyl. Now we're done with the preface this thing. Then you put none. At carbon atom number 6, we have double bond, non says 6N. It should have 6 in. Look at this. Then the final form, the priority functional group is 2 on. Now look at this. Let me tell you something so that when you see it like that, you'll not be surprised. O is a vowel. E is a vowel. When what is coming in to meet the last part of this, which is a vowel, is also a vowel, then this will drop. That's why you name it as non-cis N 2 on. So you drop the E. At times, even if you but because there are some exams you put that E, they will penalize you if it is theory question. Naming also have rules or the principles of going about it. Do you see it now? So naming have what we call principles. So you should take note of that. Naming have principles. So this question was one of the question that they asked, and you should be careful. You should take note of that. Look at this other question. Which of the following carboxylic acid have the highest boiling point? And they are giving you octanoic acid, 8 carbon, heptanoic acid, 7 carbon, decanoic acid, 10 carbon, and hexanoic. The one with the highest number of carbon atom becomes the answer. The one with the highest number of carbon atom becomes the answer to such a question. So we should take note of that. Take note. The one with the highest number of carbon atom becomes the answer to that. So please, I also want you to get acquainted with, I think we are done with this. I don't know whether, I done with this. I don't know whether you are what to, I don't know. I'm done with this compound, whether I'm just holding on for you in case you want to take it down or you don't understand how the name come about. It's pure direct unique question. Well, all this is boldly represented. Don't forget when you go and they ask you, Lucas reagent can be used to distinguish the 3 classes of alcohol is a mixture of dash and dash. You shouldn't forget that the component of Lucas is what? Anhydrous zinc chloride and concentrated hydrochloric acid. The same thing if they're asking something as regard, what I call it, Clemensin reduction. Clemensin reduction, the reagent is what? Amalgamated zinc or zinc amalgam in conc HCl. So all these things are important, and I know how we have been shouting, revolving around all this, you shouldn't forget the carbonyl compound. Don't forget that also carbonyl compound. Carbonyl compound can be identified using 2,4-dinitrophenylhydrazine. So 2,4-dinitrophenylhydrazine. All these things are important. And I know, look at this one. Which of the following is a secondary amine? We have done. How do you know primary amine? This is primary amine. Check the given amine. The number of this stand for methyl can be CH3, something like this. CH3 NH2. A primary amine, after the methyl part, have two hydrogen attached to the nitrogen atom. Now, this is a secondary amine, R prime, then NH. You just have one hydrogen. Example, CH3N, NH, and maybe CH3 here again. That is a secondary amine. While a tertiary amine is R prime, R prime prime, then N. This one does not have any hydrogen attached, meaning all the hydrogen of the ammonia have been completely replaced by the what? The what do we call it? The alkyl group. For instance, we have CH3, we have this N, have CH3 here, and have CH3. Remember, this have just one lone pair. Let me not go into all that. So if you are to name this become N-methyl methylamine. Why this one is just simply methylamine? Why this one is now what? N dimethyl methylamine. As easy as ABCD. I've done all this. All this. You see, that's why I don't well, I just proceed. Everything will go fine. Whether okay, so when they ask that kind of question, it should be a bonus mark. This one, functional group in an unknown sample can be identified by employing dash. The answer is fully, in fact, know it as FTI. Look at this. FT IRS. Fourier transform infrared spectroscopy. That is this thing. That is what we use to identify functional group in an unknown sample. Fourier transform infrared spectroscopy. All those things will come out. One thing is this which of the following compound is used as an anti-freezing agent? Don't forget ethylene glycol. Ethylene glycol, which is a dihydric alcohol. Don't forget that glycerol is trihydric alcohol. All these things are just the basic things that you need to know. Dash back official. He said, is this a question? He said, isobutanol formula condensed. Isobutanol. Please let me know what your question is so that I can attempt it. Is it that I should give the condensed formula or dash back official? Are you still here? Okay, so for isobutanol. Okay, that's back. Let me just illustrate that. Let me show you. First of all, accept C, 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 and C, OH, hydrogen, and hydrogen 1 2 1 2 1 2 1. Yes. All this one is the graphical formula for butanol. Hmm? Butanol, which I can see represent it in a skeletal form. 1, 2, 3, 4. Then I will put OH. I still butanol. This and this is still dissenting. I'm coming. Now, you see here, I want to condense it. How many? This carbon, I will squeeze it, becomes CH3. I'm coming to your this in question. This one becomes CH2, and this one becomes CH2, and this one becomes CH2OH, which I can still further condense it, knowing that what we have within are same. It becomes CH3 into CH2 of 2, then CH2OH. Are you seeing it now? So this is condensed formula of butanol. Now, when we talk about isobutanol, look at what are the isomers of butanol. First of all, we need to understand if you have this. Initially, this butan 1O. This can be butan 2O. OH will now be here. This 3 hydrogen here. Of course, 2 will be here, and 1 hydrogen will be here, and 3 will be here. So meaning I will have CH3, CH2, CHOH, and CH and CH3. This is butan 2O. First one is butan 1O. I'm not done. So you can also have it this way. Pay attention. You can also have something like this, whereby you have CH3 here. And what do you have here? You still have your maybe CH2OH. Pay attention. And here should be hydrogen. And here should now be CH3. Now, normally, if I want to condense this, it becomes CH3 and, of course, CH into CH3, then CH2OH. This is another isomer of butanol. What do we call this? This is 2-methyl-propan-1-O. Are we together? This 2-methyl-propan-1-O. Then I can still have it as CH3. Then CH. No. Let me put it OH into CH3. Are you seeing it? And then CH3. This is another isomer of butanol. And what do we name this? Since we are, remember, I'm just revolving around what I can technically call isomeric alcoholic isomers. We still have non-alcoholic isomer like ether. Now, this is what I can call 2-methyl-propan-2-O. If you talk about the ether part of it, it becomes CH3 of CH2 of O, then CH2CH3. This one is what we call ethane, and then the last one become ethane or diethyl ether. This one becomes CH3, CH2, CH2O, and CH3. These are the 2 ether isomers. But I can see craft out another one. No, it's okay. That is the 2. This one is what? Methoxypropane, 2 ether isomer and all that. So this and alcohol is said to be functional group isomerism. So please take note of that. So I don't know whether if I answered the question. You answer the question. Eze, you say circle the odd one. We're giving sodium, giving lithium, sodium lithium, we're giving boron, we're giving beryllium, we're giving magnesium and calcium chlorine. Then you have to say, and chlorine should be odd now. Maybe they are considering them based on their metallic tendencies. Because this circle, the odd ones, it come with different distance. So that is it. So any other question? Any question from me? Now when the next live session definitely will be on TikTok so that I can sit down. Yes, I cannot position my screen to paper. I'll sit down. I want us to, that is just I will not meet again. As I told you guys, we're supposed to have a session. All this when a keto group is directly attached to benzene link. Take note of those questions before you enter exam hall. So take note of them. So take note of that. So do anybody have any question or questions? Have any other this thing to drop? Okay, so I think this will take a pause so that I can come up again, but that will be on TikTok. I'm going to take a pause. I'll come up so that I will share my, I can easily focus on my paper. So that is it. It's not easy. I've stood for a while now. So please do well to subscribe. Those of you that are just joining, do well to subscribe. If possible, you can see, drop your number if you want to maybe be in our platform whereby you can easily be notified when we are making a move of any of the media classes. So please do well to subscribe. Refer all jambis that you know. Do well to subscribe. Do well to subscribe. Subscribe so that uh, yeah, the information. I think is so that my next session, which is going to be on our TikTok handle, I am going to be mind blowing. It's going to be mind blowing. Just do a keep flowing through. We try as much as I can. I'm not going to revolve around teaching. Next session is going to be a lemma of questions. Yeah, lemma of questions. Lemma of questions. Let me just give you a little time. Maybe I don't know how it's going to be, but I will notify you guys. I will notify you when next I'm coming up to the lemma of questions so that when we are done with that, I want you to walk in confidently tomorrow. Just go to the exam press and do your best. Just go to the exam press and do your best. Our TikTok handle for those of you that will join us is still Momentum, the same name that you are seeing here in our YouTube. So do well to join. Do well to join us. Do well to join us. I think with this, I will take a bow. Have a wonderful day. Don't forget to subscribe. Don't forget to subscribe. Yes. Don't forget to subscribe. Thanks for joining us. See you in our next class. Tomorrow, see you in our next class. You're going to have a session 2 for physics. So yeah. Okay. Yeah. Medical. You are recognized. Take care.